Welcome everybody to this afternoon session at Cord Build. My name is Saurav Das. I'm from the ONF, and I'm co-hosting this session with Sean Ying, who's from AT&T, and we're here to talk about our cord, what we call residential cord, and VOLTHA, which is a very important project in the cord system of projects. So, without much ado, now just wanted to remind you that the R-Cord session is actually 2 days. We'll be talking all afternoon from here till 4:30. And then there is another session that starts tomorrow. And you can look that up on the online schedule. I'm not exactly sure what time it starts, but I think it goes all afternoon tomorrow as well. One more thing I wanted to mention is that there has been a change in the schedule, last-minute change. Sean and I are going to talk for the next hour from 2 to 3, talking about R-Cord and VOLTHA. Right after, at 3 o'clock, originally, we were going to do a deep dive into the VOLTHA architecture. Sergio from Siena was going to do that. And then following that, we had two service providers, Tom Anschutz from AT&T and Manuel Paul from DT. We're going to talk about sort of an R-Cord roadmap, what R-Cord going forward. But those two talks have now been swapped. So at 3 o'clock, we'll have Tom and Manuel talk about R-Cord going forward. And then at 3:45, we'll have Sergio come and talk about VOLTHA architecture. OK, so R-Cord. Just a quick, you are already familiar with cord, so I won't spend a lot of time on this, but a quick overview is that what we want to do with cord is that we want to bring the economies of a data center, but also we want to bring the agility that a cloud provider has to the telco central offices. That's one big advantage that the telco providers have. They have location very close to the end user. And anything that we see in the future going forward, right? All these new applications that we see, AR, VR, IoT, and you name it, all these things will benefit greatly from having very low latencies and computing as close as possible to the end user. And telcos have that big advantage over Google and Microsoft and Amazon and so forth because they have location closest to the end user. It's just that in these central offices, we want to bring the economies of a data center to use open source software, white box hardware, and also in the agility that cloud providers enjoy in their massive data centers somewhere very far away, where electricity is cheap and water is cheap. We want to take the same economies and the same agility and bring that to the telco central office. So that's cord in a nutshell. Central office re-architected as a data center. And as you know, we have targeted all the possible customers, so to speak, of a telco service provider, whether it's residential, mobile, or enterprise customer. We want to bring all those customers and the services for those customers onto the common infrastructure built on bare metal hardware and open source software, right? So it's no longer, we're talking about silos for each of these customers. We're not talking about a whole bunch of boxes for enterprise customers, a different set of boxes for mobile customers, and yet another different set of boxes for the residential. We want to get rid of that. We want to bring them all these subscribers onto the same platform and provide different services on this common platform. So this talk and this session and this track is about one of those kind of subscribers, the residential subscriber. So this is what residential cord looks like. This common infrastructure remains the same. We have bare metal switching hardware and open source software with the leaf spine fabric connecting the entire infrastructure, whether that's edge computing hardware or there is access hardware on one side going to the residential subscriber, but you can also imagine to mobile and enterprise subscribers. And on the other side, the metro equipment that these central offices connect to each other and connect to the larger core network for this service provider. So this is the common cord platform. It's run by open source software, whether it's the SDN controller for which we use on us. That's a clustered SDN controller on which we have a whole bunch of apps that run. Now, these apps can be just for the infrastructure itself. For example, there is a fabric control app that manages this leaf spine fabric. But there can also be apps that are meant for the residential subscriber or providing a particular service. As Larry had mentioned in his talk before, the VNFs providing a particular service for a particular kind of service subscriber could be data plane VNFs, right? So the subscriber traffic is actually going through the VNF, maybe a VM that is instantiated in the compute nodes. Or it could be, or the service can be provided by the hardware itself and is just managed by an application that is running on top of the SDN controller. And then Larry spoke at length about the CORD controller, which we call XOS, that manages this entire infrastructure. So it's an orchestrator, but also a service creation platform. So this open source software that is managing this entire infrastructure, as well as the services for any kind of subscriber, is running in the compute nodes, right? It's just for clarity shown up there. But what is specific about residential CORD in this particular case? So you will notice these boxes over here, they refer to passive optical networks that are reaching out to the residential subscribers sitting in their homes with optical network units or network terminals. And then in the central office is the optical line terminal, the head-end box, so to speak, of this passive optical network. And this is how you do fiber to the home or fiber to the curb, going out to the residential subscriber. Now, these boxes are new. What's new about these boxes is the same philosophy that we have used over here of bare metal hardware, merchant silicon running inside the bare metal hardware, managed by open source software outside the box. What we have done with the fabric over here, we have done the exact same thing with the access devices over here. So this is, for example, an XGS PON. And XGS PON just stands for 10 gigabit symmetric PON, 10 gigabit upstream, 10 gigabit downstream. So the 10 gigabit symmetric PON boxes have merchant silicon from Broadcom running inside it. And that's it. There's very little software inside the box. That's actually being managed by this other piece of software that we call VOLTHA, that Sean will talk about extensively. VOLTHA is outside the box and is managing the optical line terminals and also interacting with the SDN controller and the apps that are running on top of it. Okay. And similarly, we have other pieces of software in the data plane. I'll talk about this in a minute. There's VSG, which stands for Virtual Subscriber Gateway, and I'll explain its functionality in a second. And then you can imagine there are other third-party services, like a CDN, that we want to provide to residential subscribers. So in a nutshell, this is the CORD network infrastructure and this open source software that is managing this entire infrastructure. And then there are a set of services that are either SDN apps, or they are, in fact, data plane VNFs or VMs that are meant for the residential subscriber. So, so a little bit more about this box over here, the VMs that we see over here called VOLTHA. What is the purpose behind VOLTHA? Well, the idea is that now we have OLTs from multiple subscribers, right? The EdgeCore OLT that I just talked about, which is bare metal, white box OLT. But we also have a number of other OLTs from a number of other vendors that are also partners with us. And what VOLTHA does is that it creates this common control and management framework. It is for all of these OLTs, right? So you can imagine that it talks northbound to the SDN controller through one of these agents. And the SDN controller is actually not PON aware. So there are a number of things in the PON, like PON level details, TCONs, gem ports, these are OMCI messages between the OLT and the ONU. These things are hidden. They are abstracted away from the SDN controller. The abstraction presented to the SDN controller is not that there is a PON, there is an OLT, there are a few ONUs in the house. The abstraction presented to the SDN controller is it's just an Ethernet switch or a pseudo Ethernet switch. So the SDN controller just programs the PON like it were programming any other Ethernet switch. And then it is the job of VOLTHA to break up those commands into what goes into the OLT and what goes into the ONU, maybe through OMCI messages, right? So these are the kind of PON level details that are hidden away, that are abstracted from the SDN controller. That's the number one functionality of VOLTHA. The second one is that it provides this common control and management framework so that whatever comes from top, there is an API over here. right? And it is the job of these adapters to actually control and configure the boxes below, whether it's the OLTs, which are shown over here, or the ONUs, right? So we have written a number of adapters for a number of different devices. The vendors have themselves contributed a number of adapters, and Sean will tell you more about that. But to give you a picture of how this all works together, this is a recent demonstration that we did just last month in Berlin at the Broadband World Forum. And what you see over here is the smallest form factor that you can imagine of a cord deployment. So you have what we call the head node, where you have ONOS running, the SDN controller, XOS, and so on, and OpenStack with which we instantiate VMs, MAS, and Radius server, and a bunch of other things that are running inside the cord head node. We have only one compute node, which is meant for data plane VMs. And in that compute node, we have VOLTHA running. VOLTHA is managing these OLTs. And we have VSG, which I'll talk about in a minute. So this compute node is then connected to the fabric switch, which is also white box, also built on bare metal switches, and controlled by ONOS. So instead of a full fabric, a full leaf spine fabric, we have a single switch over here, which is this one. It's a Tomahawk 32 by 100 gig switch. And that's connecting to the upstream, that's connecting to the compute node, and it's connecting to the access devices. And these two access devices in this demonstration, one was the EdgeCore, the white box OLT, and another one, which is a Nokia product. And you'll hear about that tomorrow in the afternoon session as well. And each OLT is connected to the ONUs that are at the residence and to a residential gateway that is providing Wi-Fi access. And we had laptops and other equipment connected over Wi-Fi. So this was the setup at the demo, and this is how it works. So first up, when we bring up a subscriber, right? Let's say a subscriber came up at a home, and what we did is we activated this ONU, and the first step after that is to authenticate the residential gateway that is sitting behind that ONU. So the authentication step happens like this. Once you activate this, ONOS goes ahead and via VOLTHA programs this box as to say that if you see authentication packets, send them up to me. So when the authentication packet comes, they go not through the data plane, but then through to the compute node and onto VOLTHA and then onto ONOS. And what ONOS does is there is an AAA app written on it that sends it to the Radius server for it to get authenticated. If the authentication fails, the traffic from that particular ONU will be blocked right here, right? But once the authentication succeeds, there's a number of things that happen. Okay, so first of all, we want to provision some VLANs for that particular subscriber. So there is a subscriber VLAN, a C VLAN, and then as a service provider VLAN, the S VLAN that gets allocated. That is told to VOLTHA, and then VOLTHA in turn either tells the OLT to put in the S VLAN and the ONU to put in the C VLAN. Okay? At the same time, ONOS also tells the white box fabric that is going to forward those VLANs to the compute node, tells the virtual switch inside the compute node to forward those VLANs as well to this VSG that XOS has created via OpenStack for that particular subscriber. Okay? So there's a number of things that are happening as soon as the subscriber is authenticated. Okay, so how does data plane traffic then go through? Well, data plane traffic takes exactly the step, gets the C VLAN, gets the S VLAN, gets forwarded through the fabric, through the virtual switch, and then onto the VSG for that particular subscriber, and then goes back out to the internet. If that traffic was meant for the internet, that's exactly the steps that it would take. But the purpose of going through the VSG, which stands for Virtual Subscriber Gateway, is that it is a gateway for additional services that you might want to provide for that particular residential subscriber. So what we also showed was that, for example, I'm at home, so I can go to a subscriber portal, and then I can change, and I can do parental control over there. So for example, I might say that, okay, I have a child at home. I don't want the child to mistakenly go to some adult website, let's say. So let me go to the subscriber portal, and there I can see the devices that are in my home. And for a particular device, I'm going to do some parental control. So what happens in the back end is that this goes to XOS. XOS figures out, okay, this is the VSG for this particular subscriber. And for that particular device that requires parental control, I'm going to change the access controls inside the VSG. So when such traffic does show up, it gets blocked at the VSG. And you can imagine there are other services that we can provide in the similar way. For example, now if I can go to an operator view instead of the subscriber view, an operator can decide, well, I'm going to block this subscriber because for whatever reason hasn't paid the bills or any other reason. Or I can say that there are traffic that I think can better be served by a CDN, which is at that edge compute, not somewhere far away, sitting on the internet. I'm going to say my CDN is at the edge compute, and I'm going to take this subscriber's traffic and service it through the CDN. So it's essentially your subscriber gateway. So this is the demonstration that we showed. It's exactly the same equipment, the EdgeCore OLT, the Nokia OLT, ONUs and residential gateways. Below the EdgeCore OLT was the white box switch, and then two servers. One was the head node, and one was the compute node. So hopefully, this brief introduction has given you a good idea about what is RCORD, what are its pieces, what is the smallest instantiation of RCORD, and how you can use it to provide residential services on this common platform of bare metal hardware and open source software. So now I'd like to invite Sean to tell you a lot more about the VOLTHA project, which is an important component of CORD.
I'm Sean Ying. I have the pleasure to work with the ONF. The role I'm playing here, I think earlier in the morning we'll talk about for different core project. There's that we call product owner. So I'm AT&T. We started working on this project with the multiple partners, and then it actually started like if Tom is here, maybe he knows the history a little bit better, about maybe 2016, and then we started with the GPON, and then now we move on to the XGS PON. So right now, in this phase, I'm the product owner for this VOLTHA project. Is that this box?
No, it's the
okay.
One. Yeah.
So VOLTHA, virtual optical network termination, hardware abstraction. So that's VOLTHA is about. Initially, we have the PON that include the GPON device and EPON device. I believe that's the Tibet, the hardware, and the XGS PON. Ultimately, we like to include GDAFast, and GPON2, DOCSIS, and Ethernet into the framework. You'll see, the VOLTHA. The idea about the VOLTHA is a hardware abstraction, which will provide technology and hardware agnostic support for various different access networks. So that's the beauty of this device. The key value of the VOLTHA, I think, the unified. I'm a service provider, right? So each different OLT has their own EMSs, and then every time when you deploy something, all the IT testing, all the different variants, that really costs a lot of money. So unified OEM abstraction, that's probably the most important factor why the service provider right now is very interested in this platform, which means you can have a common API talking to your northbound OSS, BSS, and through the SDN controller. Then you will have a common unified management network to manage your device. So service provider, how many of you here are service providers? Okay, so I hope you share the nightmare, the issue we're trying to address here. The control and management of legacy access is a mess, right? Depends on how many OLT or GDAFast you have. You have different EMSs over there. So all the life cycle support, that's a nightmare. So what service provider want? We want a given exit technology would provide an identical control and management interface. That's a very good idea, right? But it's not happening just yet. So VOLTA will provide the first step about marching over to that goal. Oh, got it. Today and tomorrow, we'll have the subject matter expert to talk about what VOLTA framework is actually about. So I'm not going to go into the detail. The product owner doesn't need to know the architecture, right? So, but this is the updated framework for the VOLTA release 1.0. So you have, all the VOLTA container communicates through the gRPC protocol. And then the main container published events from all the events coming from the hardware go out through the Kafka interface to your northbound systems. And then the persistent data will be captured. Right now for VOLTA 1.0 is the console. The southbound, the ONT, OLT, ONT adapters, sometimes we use the ONT, some people use ONU, so it's sort of exchangeable right now. So the OLT, ONT right now is within the VOLTA core itself. That's the 1.0 release and 1.1 release. But we target to separate the OLT, ONT adapter into its own container in the VOLTA 2.0 release. We'll talk about that a little bit later. And split adapter, the OLT adapter and the ONU adapter are separate, okay? So OLT, each OLT device will have its own OLT adapter, and each ONU device will have its own ONU adapter. The idea about the design of this framework, this concept is through the different adapter pairing, you can establish the OLT, ONT interoperability. Any questions so far? Okay. Oh, this one actually have So this is, I'd like to talk a little bit about the OLT, ONT interoperability. So when the OLT comes up, or we use a VOLTA to pre-provision this OLT device and assign this device to an OLT adapter, that enabled the OLT, the OLT start being controlled by the VOLTA. So the OLT will, based on the adapter, and then when the ONU comes up, right? ONU comes up. Usually there will be an event that that's a new ONT. It had been discovered on the POM port. So what shall you do? What shall we do about it? Then you assign this ONU with the ONU adapter. Within the ONU adapter, they actually have the OMCI messages. So because of this, so the OMCI sequence a message using this to send out to be populated into the OLT adapter, and then ONT and OLT will sync up. Okay, all the plume message exchanges, ideally with this framework, it will work. But so far, we have not proven that's correct. So I'm looking forward to, I think for the service provider, it is our goal to have the flexibility. We don't have to nail down the OLT or an ONT, because every time if we choose this one, we'll have to use their own ONU. So the OLT, ONT interoperability will be a major part of the development of this framework. VOLTA project. So initially, the VOLTA project is sort of like a brigade under the ARC core. It was formed by the ON lab, previous the ONF, it's called ON lab before, Sienna Blue Planet, and Tibet as a main contributor at the time. And it supported the OLT hardware is Tibet, PMC, and Broadcom Maple B0 chip. This is all happening, I think, the first quarter before the first quarter of this year. And AT&T in January through May, we have a series of the Plugfest. So we have multiple vendors to come in to AT&T lab to do the proof of concept of the VOLTHA framework. And it ended up is every vendor submit, flooded in with all the contribution. But so for example, the AAA app, since we have 4 vendors, they have 4 different versions of the AAA app on Onos. So we found out that's not a very good use of the community resources. So what would be the best way to do? Let's group everybody together and then work on the project and divide and conquer. So on May 19th this year, we established a separate VOLTHA project, was established. I, Xiaoying, as a Scrum Master, the initial, not Scrum Master, product owner. The Scrum Master was Donna and then Yuan from ONF. Right now, we have a new pair of the Scrum Master, Julie Lorenzen from AT&T and Tim Marshall from Redis. Additional technical lead were added. So then the technical lead, basically each vendor company elect themselves at what area of the expertise they can contribute. We targeted the August 31st for VOLTHA release 1.0. So I'm talking an old story right now. And after VOLTHA 1.0 release, we added Nokia OLT ONT. We added Atran OLT ONT, Calyx, and the Edge core, the surround described, white box OLT, plus existing we have Tibet still in place, and the GPON OLT adapter still within the VOLTHA core. Okay. So what's the feature set? So during the meeting, we decided in order for us to service provider to deploy VOLTHA, we need to have high availability. So the VOLTHA high availability become probably one of the top item to be executed and then delivered for the 1.0. At the time, I think the Sergio will be the one who describe what the high availability is going to be today, right? So I'm not going to go into the detail. Remove internet access dependency. I think a lot of times, just like people say, well, when I install the VOLTHA, there's always internet there. No, that's not true, right? So we have to remove that dependency. So that's also one of the high priority issue we want to address. Power management configuration. That one is put in because the broadband forum has a WT 385 implementation. We believe it would be a good idea to have VOLTHA to support the WT385 implementation so we can, in the future, use broadband forum's common EM model or expand EM model so whatever developed in broadband world forum can be translated or implemented into VOLTHA. So that mostly, I think a lot of times, service providers like to pre-provision things. So that will bulk provision things. So that will enable the provisioning for the servers that way. And auto detect ONU registration, control plane, device management. That basically you want to admin down, admin up the OLT or ONT or software download. It's a big scope. Right now, if you have ever visited the Jira, there's only 6 or 8 story in there. So it's a subset of the story has been developed, but there's a whole big set is to be developed. VOLTHA security. We know security is always the most important issue, but always the last one to be implemented. So we bring it up front, say we need to address the VOLTHA security, but the implementation portion is pretty minimal for this release right now. The Edge core, the ASFVOLT 16 OLT, I think you're going to hear that a lot tomorrow. That's the first, I think this week in Santa Clara, there's a tip, right? The OCP project, Open Compute project. AT&T has submitted a 16-port the OOT, XGS-PON OOT based on the Broadcom Maple B0 chip. So that's the first implementation of this specification. And of course, we like to showcase using the open source project to manage the open compute OOT that makes sense. So the edge core OOT, that was one of the top item to be implemented or had been implemented in the VOLTHA 1.0 and 1.1 series. So there's some status here. It is something just, if you go to Jira, you pull it out and then try to, you can see how many completion of the epic and story has been developed. Behind it, there are lots of bugs. So all the bugs also being fixed. So that's the progress. But again, the VOLTHA 1.0 and 1.1, the development of that is supporting a proof of concept experiment right now, but we're marching over for productization of this platform. One thing I want to mention is the VOLTHA, the design, the intent of VOLTHA is not bound within our core. It could be implemented within our core or outside our core, or even on the hardware, is the OOT box itself. So that's the intent of the design. What's the purpose? So you have a common API. The service provider can use the common management system, control system to manage in the device. Any questions so far? Okay. So this is the milestone. So originally, we want to release the VOLTHA 1.0 on August 31st, but we actually released it on the September 8th. We have a lot of technical lead here. So that's a VOLTHA 1.0 release. At the same time, we have a parallel release, the edge core. So I think this one, do we have the edge core part? Probably not. After the VOLTHA 1.0 release, we use AT&T Lab as a QA testing. It's very interesting. So a lot of the ticket that's being opened during the AT&T Lab testing, but the community worked together to get that resolved. So VOLTHA 1.1 actually just tagged and released yesterday. Kim? Almost. So VOLTHA 1.1 actually is the official release of the VOLTHA 1.0 plus the edge core adapter. So that composed as a VOLTHA 1.1. And we are targeted to have the VOLTHA 1.2 release the first week of the December. What do we do next? So originally we start with the VOLTHA 2.0 planning. And then the delivery of the VOLTHA 2.0 will be the end of the second quarter of 2018. However, we found the OpenOMCI probably is one of the hot items we need to address. So we are going to squeeze in a VOLTHA 1.3 at the end of first quarter of 2018. And those features we're going to talk about tomorrow. Any question? Yeah, this is the support branch of 1.0 and 1.1 release. I think I'm just making a reference of this. So the 1.1 release branch just created it, but most of the bug fix and new features between 1.1 and 1.2, there's not going to be any new feature introduced. Mostly is the bug fix. So all the new fix will be on the master branch, and our subject matter experts, basically two of them, will try to cherry picking, make sure the 1.1 release and the master branch are synced up. Okay. Okay. So these some activity we talk about. So one thing is 1.3 March and 2.0 June next year. And then VOLTA 2, the Edge Core full release probably will be also June next year. Activity, like Ralph said, we have the Broadband World Forum 2 weeks ago in Berlin. We have received a lot of attention on site. And VOLTA 1.1 and 1.2 field trials is actually happening in, I think, in many carriers. I think mostly in Europe. So it's definitely getting a lot of attraction. The our core integration to the satisfying cactus, is that still correct information? Okay. That's it. But before I end, this is experience I really cherish. In some way it is, we work, I mentioned about technical lead. Who are the technical leads? Nokia, and then Ciena, Radisys, Atran, Calix. Those are competitors in the space of the OLT. Maybe not Radisys, but they work together. They work together under the project, and they discuss, they argue, I'm giving you the part of talk, like, feel good talk, but it is a very, very good experience working with these supplier and vendors. They're technical, professional, very professional, and then discuss matters, and then deliver things on time. That's really, I think the whole project probably has at least 40, 60 people behind the scene working on delivering all the features. So I want to use this opportunity to appreciate their devotion. And then at the meantime, we'd like to invite all the service providers, if you're interested or you're planning trying to include VOLTA as one of your field trial proof of concept, we welcome for your contribution for your feature. We are right now in the progress of defining the VOLTA 2.0 feature set priority list. So I'm going to present that tomorrow, but I'm welcome for the input for let's set a priority for those lists. So it will not be just AT&T's list. Okay, so question.
Thank you, Sean. We have about 10 minutes for questions before we all take a coffee break for 15 minutes. And then at 3:15 is when we will have Tom Anschutz and Manuel from DT talking about RCORD going forward. So 10 minutes for questions. Any questions for Sean and me? Yeah, go ahead.
Yeah, so I have questions. In your talk about this OLT and ONU interoperabilities.
Correct.
So basically I heard you said is that is very important and critical area. So far it's not proved the concept. So am I listening?
So far, we have not proven that yet, because I think right now, because of the schedule, the people want to show what's working, right? So it's more. I believe it's more comfortable to pair up the OLT. Most of the participants, they have their own OLT and their own ONT. So they want to make sure that work first, and then they will go beyond that. So I think there will be some tweaking. For example, maybe have an OMCI library somewhere. So with the Open OMCI specification, AT&T released the Open OMCI specification. I think Verizon also released that. So we need to. I think that's for the next few weeks. We need to verify how exactly we can implement those information.
So my understanding from what you said is basically it's a software level issues.
Yes.
Okay. So it's a multi-vendor compatibility issue, or it's It's just synchronization issues between this OLT and ONU adapters.
I don't know. Maybe there's some hardware vendor here can explain some of the.
Yeah, so every OLT works with their own ONUs, right? So, and the message of communication is OMCI. And what happens with communication protocols is that at some point you want to do something, and it's not part of the spec, and then you make your own extensions, right? So those extensions are not going to work with anybody else's ONU,
I see.
right? So that's why what AT&T has done is come up with an open OMCI spec, and that's probably the first step towards interoperability. So if everyone works with open OMCI, that can go a long way in this kind of interoperability between OLTs and ONUs.
So it's the hardware compatibility issues with the new specs. Can I take this?
Yeah, you have to adopt something like the open OMCI
Okay.
spec.
Okay, got it.
Correct.
Okay, thank you.
But I think it's all the hardware should be able to support it, but it's
Yes,
its own
okay.
software stack.
Okay, I got it. Okay, thank you.
Thank you.
Any other questions? Yes.
So traffic shaping for the subscriber traffic, is it done on the VSG?
Yeah, so today it's done on the VSG, and we realized that that functionality can pretty easily be done in the fabric as well. Actually, in some cases, it can also be done in the OLT, because if you look at the edge core OLT, the bare metal OLT that I was talking about, it has 8 maple chips. Each maple chip supports 2 ports of XGS-PON, but behind these maple chips is a fully functional Ethernet switching chip, which happens to be the Qumran line from Broadcom. And that has all the functionality that you need for doing this kind of traffic shaping. So we are, and I think Tom Anschutz and also Manuel will probably talk about some efforts where we are thinking about taking this functionality out of the compute nodes where it is right now, and then moving it into the hardware. So you'll hear more in the next talk when we come back at 3:15.
And also for the traffic management, the VOLTHA will definitely include those in the 2.0 release, because the ONU need to do some of the shaping themselves too.
So did I hear right, in the 2.0 release from the previous deck, you would no longer need to have VOLTHA flow through data plane and compute? Is that a target then, or not? Because
Not clear what the question is, sorry.
your deck had shown the VOLTHA
The
pieces
previous-
having a...
Let me get to that slide, so maybe that'll help.
Right there.
Like this one?
Yeah,
Okay.
So you have that in the compute node, and you showed it as part of the data plane path.
No, so
Okay,
let me clarify.
because that didn't make sense to me.
Okay, so this is talking about authentication. You don't see the ONU anymore. That's when we were authenticating a remote gateway behind the ONU,
Yep.
right? So those 802.1x packets come over here. Now this is so then they get encapsulated into the OpenFlow protocol, and all the way up to the ONOS. So this is no longer data plane now. It now becomes part of the control plane. The control plane happens to be in the same, it's in-band control, so it happens to be in the, or go over the same fabric. But the fabric no longer at this point sees the 802.1x packets. What it's seeing is the connection between this box and VOLTHA. Okay? So only these control plane packets, the 802.1x packets, are the ones that are going to ONOS and to the Radius server and coming back. The actual data plane traffics that get double VLAN tagged, those are the ones that are still following the same and going to the compute node right now to the VSG. But as you will hear in the next talk, there are some efforts to move some of this functionality down into the hardware, like the traffic shaping that you mentioned, so that most data plane traffic, if there is no need for extra third-party services, that data plane traffic can stay in the fast path to the internet. If the subscriber has only asked for internet traffic, communications, right? So that stays in the hardware, okay? And only when you want to provide some extra third-party services, then only for that particular traffic do you go off of the fast path into the compute nodes and to VNFs over there.
Can you sequence to your next animation for this? Because it
Sorry?
showed.
Next
sequence
sequence.
again.
This one?
Yeah, because that was the sequence that was confusing me, going up and through VOLTHA there. That seemed to be data plane, but that is not.
No, this is all control. This was just explaining that once a subscriber has been authenticated, what all happens.
Okay.
Right? So ONOS, being the SDN controller, tells VOLTHA that for this particular subscriber, I want this C tag and this S tag.
Okay.
VOLTHA then says, because remember, from the ONOS perspective, it's just programming a switch. And it's saying, okay, I want a C tag and an S tag. Then it comes to VOLTHA, and VOLTHA says, okay, the C tag actually needs to be pushed at the ONU, and the S tag needs to be pushed in the OLT. So then, over its control channels, through the southbound adapter for this particular device, different southbound adapter for the other device, but essentially doing the same thing. What it's saying is that put in a flow rule over here that pushes the S tag. And then, using the OMCI messaging, again, it goes through here to the ONU and says, okay, put in a flow rule that says push the C tag, right? So all this dashed lines over here is really just control plane things happening to then activate the data plane.
Okay.
And this is the data plane, right?
Slides. Thank you.
Yeah.
That makes sense.
And doing our QA testing, the radius actually is somewhere in the network, so it's not within the fabric or not the head nodes. So it also supports that way. So the owners have the proxy, and then they send the AOT.1x proxy message out through the same the top of rack switches, but it's outside the core.
Okay, I think we have time for one last question before we take the coffee break. Yes, go ahead.
Multicast handling.
Multicast. Actually, great that you bring it up because I actually forgot to talk about it. And this,
You mean you skip a slide?
I forgot. So what you see over here, this green line, that actually multicast traffic. And basically what's happening is that you're using IP. So somebody at home is going through the set-top box, changing channels on their TV. And the change of those channels is projected out as an IGMP packet, right? And that IGMP packet is again snooped and sent to ONOS. Okay? Then ONOS figures out, okay, so now the subscriber is asking for this multicast group, right? And that multicast video source is actually upstream somewhere. Okay? So what ONOS then does is that it figures out that for a particular multicast group, I have this many subscribers asking for it at these particular locations. Because it's SDN controlled, it first programs the fabric switch. It also programs the particular OLTs that have subscribers that have asked for that multicast group. So the replication happens in two levels. It first happens in the fabric to reach a particular OLT or a particular PON, and then within that PON, there is more multicast replication happening inside the OLT to reach those particular subscribers. And this is a dynamic system because, change multicast groups, they get snooped. Maybe the multicast traffic is already there in the system, or it has to be requested from upstream, and that's a PIM SSM request.
Does the owners initiate the message?
Yes, that's right. There is a PIM app in ONOS on one side, and then there is an IGMP snooping app on the other side. So it marries the two and manages the infrastructure to create the multicast tree. Okay.
And again, it worked.
Okay, thank you very much.